So, good day, students. Here we are for section 1.3, which is called Collecting Sample Data. And the key idea that we want to work on is we really want to begin to talk about how do you collect data appropriately. So, when we go to look at experiments later on, when we're trying to decide if we can actually apply the mathematical tools that we know, we want to at least stop for a moment and ask ourselves, was this data collected appropriately? And so, how did this sample come about? So, that's really sort of the key that we're looking at. How do we collect data appropriately? Now, there is something called the gold standard when you design what's called an experiment. Now, an experiment is where you have randomly selected subjects in that you're studying, however, whatever the randomness is. You're studying wolves in the wild, or you're studying medical treatment for people. You have some kind of randomly selected subjects. But then what also happens is you create what is called a placebo treatment group. Sorry, that C's bad. Placebo treatment group. Okay? And what's that mean? You get your random subjects, you split them into two pieces, and one piece gets the placebo. A placebo is a fake treatment. So, like in medical studies, you'll give yourself a shot that's just saline solution, but you don't know it. You mix it like the medicine and everything. That's what happened in mine. And you give yourself a shot just like everybody does, but it's a fake shot. Or you'll take a pill, and it's essentially a fake pill made to taste like the other medicines. So you get all the feelings that you're taking real medicine, but it's just sugar or salt, something like that. And then the treatment would be like the actual medication you get. Now, what if you're studying wolves in the wild or something like that? Well, what you might do is you might have a placebo group that are wolves just in their natural environment, taking care of themselves, doing stuff like that. And then you might have a treatment group where, gosh, I don't know, how would you treat wolves? You might introduce a new pack into their area, all right, and then see what happens. Compare the interaction of an old pack with this treatment, a new pack in their area, and versus the other wolves that just have their area on their own, and you can begin to see the different behaviors. All right, so treatments can be all kinds of things. In medical studies, you are giving fake medicine or in real medicine. Another place for studies would be sociological, psychological, or educational studies. In those cases, say like teachers are trying to discover a better method for teaching statistics. And so one group will be taught by whatever the traditional methods are of students, and then another group, maybe the same teacher or very similar styled teacher, would teach using inquiry methods of instruction. And then you would compare the results. What do the students understand? What kinds of things were different about their learning? Did they learn better, or was it just differently? And then you begin to make conclusions about whether that treatment is a better method of teaching. So that's why it's the gold standard. All right. I would just mention when you read studies that have this sort of experimental thing where a treatment was added, you really want to get a sense of are there any problems with the treatment as opposed to the placebo. And so we'll talk about some of those things in a moment. So in general, an experiment is where you apply some treatment and then observe results. Okay? That's what an experiment is. Okay? Now, the subjects in the experiment are going to be called experimental units or just subjects. Okay? So you want to kind of keep that in mind, remember that vocabulary. If you're asked to describe the subjects of an experiment, then you'll describe, what are the people and what are the characteristics of the people. Now, yesterday I told you about the human growth hormone experiments. In my case, it was people who did not produce human growth hormone on their own, whether that was by genetic issue or by surgical procedure or disease. All right. All of us were in the study because we did not produce our own human growth hormone. All right. And so we were subjects. If they're not people, that's typically when they're called experimental units. Now, lots and lots of studies happen to not actually apply a treatment. And what happens in that case is they become observational studies. What would an observational study be? You're just going to look at the people in the experiment and observe and measure certain characteristics. Okay? You don't attempt to modify anything, you're just observing. In fact, even when you have a true experiment with placebo treatment, essentially the placebo group is an observational study. You're just measuring all their characteristics, what's going on with their lives, everything that's happening, and you observe that in the placebo group. And then the treatment group, you're going to observe all those same characteristics after they receive whatever the treatment is. Okay? But in general, lots of studies are observational studies where you just look at stuff. Sometimes you're trying to get an idea what kind of treatment you want to give. So you just observe and try to figure out what kinds of treatments might be best. All right? And then once you do that, then you proceed forward. And lots of science proceeds in this way. Okay, now let's continue on with talking about the design of experiments. All right? There are 3 things that each good experiment should have. That's replication, blinding, and randomness. So let's talk about each one of these. Replication just means that the experiment can be repeated. Okay? Experiment repeated. So somebody can copy all your procedures, get their own subjects for it, and they should be able to get very similar results. Now, sometimes what happens is when experiments are replicated, the results are not the same. Maybe the first time you did it, it was sort of an unusual situation that popped up, but then the more usual ones pop up when the experiment is replicated. Okay? So you want to always have replication, and that's why people will do famous studies over again. Okay? Now, the other thing you want to have is you want to have blinding. So what's blinding? Well, once you have the experimental units or subjects in a sample, you want to assign them to groups, usually the placebo group, called the control group, or the treatment group. And when you assign them to the groups, you do that in a random way where you don't know where they're going. Okay? So when I was in my human growth hormone experiments way back in the 90s, what happened is with the blinding is I got assigned to a group, and my doctor and the nurses collecting all the data, they did not know which group I was in. Now, they might make guesses because maybe the treatment was actually working, it was actually doing something. But in general, beyond their own guesses, they don't know what the groups are. They just collect the data. And so the reason this is done is to eliminate, like the bias that the doctors might have. All right. So it's called blinding, where even the people who are doing the experiment don't know what groups people are in. Okay. The final thing you need is a sense of randomness. And so when you go to assign people to those groups, you want to do it in a random sort of way. And so they'll have some kind of random number generators, or they'll throw names into a computer and it'll spit them out. Or they'll do something that is some sort of simple random sampling. And what's simple random sample? That means every possible sample of the same size has an equal chance of occurring. Okay? Now, there are procedures for this. But if say the sample was 20 people, n equals 20, that was the sample size, and you had a population of hundreds of thousands, all right, of people who would fit that medical category. Say they had high cholesterol, but good blood pressure, all right? And so you were wanting to test a new cholesterol medication, but you suspected there might be blood pressure side effects. So based on that, you would want people to fit the group, and you have 20 people in your group, you give them the new blood pressure or cholesterol medication, and then you would observe to see whether their blood pressure went up or down or stayed the same, right? Now, to get these 20 people, remember, if you have the gold standard, you have two groups, that'd be two groups of 20 people in each group, and one of the groups is the control placebo group, the other group is the treatment group. But each group of size 20 would have exactly the same chances of occurring as any other group of size 20. So in other words, when they went to pick people who would fit the experiment, they would use some sort of random procedure to get those people. And then they would randomly assign, from the people they selected, they would assign some to the group. And so by keeping this random at all situations, it creates simple random samples, okay? Which means all samples of the same size have the same chance of occurring. All right? Next thing. Okay, so these are all examples of sampling, okay? And we want to determine if they're going to help us get a random sample. So systematic sampling is a pretty good way to get a random sample. It's quick, and it works okay. What you do is you just line up, everybody gets lined up alphabetically or something like that. And then what you do is you pick like 4, 14, 24, 34, 44. You pick all of those numbers. So you do it in a systematic way. Or you have everybody's ID number on a college campus, and you pick only the ID numbers where the last two digits are between 0 and 9. All right, so 00, 01, 02, 03, 04, 05. And so systematically, it doesn't matter what any of the other digits in the ID are, you're just looking at the last two, and you systematically pick those people and put them in your sample. Okay? And so systematic samples work that way. Okay? You just pick a starting point and then you select somebody like every fourth person, every 10th person, or whatever. Okay? Now, convenience sampling, we just use what's at hand. So if you were going to like demonstrate an experiment and you wanted to show how much Simpson University students loved the psychology department more than the nursing department, all right? And so you wanted to do that, but all you did was ask your 4 friends in your room, right? And they were all nursing students. Well, that would be a convenient sample, and it very likely is highly biased. It just means you don't want to spend the time to do something that actually creates a simple random sample. And so the other two methods are stratified and cluster. And the way these work is this way. In stratified sampling, you divide the population into subgroups so that the subjects within the same subgroup share the same characteristic. Okay? So, for instance, in a stratified sampling, maybe we want to make sure gender is one of the characteristics we would sample for. And so, and say we wanted to mimic the population in the US, all right? So gender in the US, I think it's about 52% female and about 48% male. And you asked, well, why is it that? Well, it's mostly because males are either in occupations or they're in wars, and so they die at higher rates. And so there are fewer of them over time. And so, but anyway, that's why there tend to be a higher percentage of women. So anyway, you say you were going to sample students on the Simpson campus, but you wanted it to mimic the population of the United States. All right. And so what you would do is you'd pick a strata, you'd call it gender. And there were 2 categories, male and female. And then you'd want it to mimic the US. So as you randomly selected females, you would want to make sure 52% of your final group, so say it was 100, so 52 out of 100 were female, and then 48 out of 100 were male. And now your sample would mirror the population of the United States for the strata gender, okay? Now, you can imagine that what they do when they make stratified samples, not only do they do gender, they might do race, they might do age, they might do income, okay? And so you create one strata would be your white, your under 20, your income is less than $20,000, and you're male. Okay? And another strata might be your African American, your age is 20 to 25, your income level is $30,000 to $40,000, and your gender is female. All right? And so what they would do is they were looking for people in their sample, they would look for people and then randomly select from those groups ones that would fit all those categories. And you see, the more categories you create, that makes more strata. So the more qualities you want to take into account creates more strata. Now, lots and lots of surveys do stratified sampling, okay, where they want certain characteristics. But the challenge is every time you add another category, you double the number of different groups you have. And the problem is even though maybe I take race, gender, age, and income into account, but there are lots of other categories that distinguish people. Gender, race, age, and income are not the only things that distinguish people. And this is what we are, I think, learning in our DEI age, is that these kinds of things do not really determine people and their opinions, that there's much, much more to that than just these kinds of things. No matter how refined we get, there's always something else that will distinguish somebody from something else. For instance, just a quick example, think of my brothers and I, all right? We match on all kinds of characteristics, all right? We're all over 55. We're all the same race. We all have the same parents. We all grew up in a single parent home. We are all male. Our income levels are approximately the same. And you could go on and on and on and on. But then we're so different. Turns out my younger brother was an athlete. And my youngest brother, he was an athlete and wanted to do that. My other brother was a woodshop geek. I was a math geek. and so if you did not take our subject preferences in school into account, you would have missed some things that made us different. Our political, as far as me and my brothers, one of us is conservative, one of us is liberal, and one of us kind of middle of the road. We're all completely different. And so one of us doesn't drink at all. One of us drinks all the time. And the other one is sort of just a social drinker, one drink at a time, socially. So we're all completely different, all right? On so many characteristics, even though you could grab lots of stratas that make us the same. And then all of a sudden, if you want to interview us for political opinions or educational opinions, all of a sudden our opinions vary widely, even though on so many characteristics we're the same. So there are problems with this, even though you try to avoid them. Cluster sampling is sort of similar in that you divide the population into sections. Now, in this case, it kind of clustering, what you do in this case, the clusters might be like voting precincts. So you take all the voting precincts in the United States, all right? And then what you do is you randomly select a voting precinct, right? And then you randomly select from that, within that precinct, there might be, a dozen drop boxes and a couple of places where people voted, all right? And so you would then you randomly select from all the precincts in the U.S., and then once you get those precincts, you might randomly select some drop boxes or voting sites, right? And those are clusters. And until you get, down to a particular cluster, and then you might take all the data from that cluster. And so this is how that works. So I'd encourage you to look at that, read the examples in the book, and that's a good thing. All right. There is something called multi-stage sampling, where they'll use some combination of these things. All right. So, for instance, they'll do some clusters, and then they might stratify the people based on characteristics that they want to check out. Okay. Oh my gosh, how exciting. We're almost done. The very next thing then that we do is in experiments, um, we want to avoid what are called confounding variables. What's a confounding variable? A confounding variable is a variable that could be just as easily causing the problem. Okay? So here's a fact. It turns out that electricity usage goes up as more ice cream is sold. Wait a second. You're telling me that sales of ice cream causes higher electrical usage? Oh no, there might be a confounding variable. Can you think of it? Oh, maybe it's just summer and it's hot. And so people buy ice cream to cool down and they turn up their air conditioners to cool down, right? Confounding variable, summer. So one of the things when you create an experiment, why you want to make your subjects very similar to each other and etc., is to avoid confounding variables. All right. Now, the way you can do that is you do two things. You do a completely randomized experimental design. Holy smokes, completely randomized experimental design. Oh, I got to abbreviate all of that, right? A completely randomized experimental design where you assign subjects to treatment and placebo groups through some sort of random selection. You can also do a randomized block design. Randomized block design. Randomized block design means you make subjects with similar characteristics. So for instance, I want 10 women and 10 men in the placebo group, 10 men and 10 women in the treatment group. And besides being men and women, I'd like the men to all be similar ages and weights. I would like those things to match up. So, I might have a 25-year-old in one group and a 26-year-old in one group, and they both weigh about 180 pounds. Okay, so they're kind of matched up with each other and similar. And I want to try and match things up in some sort of randomized block design. And I can do that with various characteristics. And then you can also do sort of matched pairs, sometimes twin studies. They things are naturally paired like identical twins. And so what you'll do is you'll have two treatment groups, and one group gets one treatment and a placebo, while the other group gets the other treatment and a placebo. And so now you're trying to compare if the two treatments are different. Now, I did this as well. I did a second study on human growth hormone, but what they were doing was they were trying to find a test that would detect human growth hormone. In other words, some tests that would actually cause them to see the presence of human growth hormone in somebody or cause your body to secrete it. And so they kind of had us in a matched pair design because they would give us different treatments, and then they would compare and see how those different treatments were working. All right. And then they have what's called a rigorously controlled design, where you carefully assign subjects to different groups. and you're paying attention to the characteristics. So rather than doing it randomly or blindly, you're looking at it very on purpose. Okay? Oops, sorry. With experiments, there are various kinds of studies that can be done. There's one called cross-sectional study. There's a retrospective study. And there's a prospective study. And so what kinds of studies are those? Well, cross-sectional is where the data are all observed all at the same period of time. So it's all collected, the people in the study, everything is collected all at the same time. Retrospective is where you look at the data from the past, and prospective is where data is going to be collected in the future. All right? And those are just different kinds of studies that can be set up in these experimental designs. Okay? Finally, what's the issue? Well, the issue is you want to avoid something called sampling error. Whenever you make a sample, it's not exactly like the population. But the better you choose your sample, the more you follow the correct procedures for doing these kinds of things, you can minimize the type of error that comes from the sample. Okay? And that's what we want to do. It's just an error. Sampling error is just an error caused by the differences between the sample and the population. Okay? Now, there's a non-sampling error. Non-sampling error is human error. You're entering the data and you overlook a page of data or something. It just gets lost, right? Human error causes the problem, and it creates a non-sampling error. Now, it could be bias. You might have bias when you were trying to randomly select people in your sample, or you might have a bias towards the treatment. And so if you know what your treatment group is, you might record things in a more positive manner than you should. Okay? And then there's what's called non-random sampling error, which is that your sampling method is not random. So non-random sampling error. And that is the last bit of vocabulary for this chapter. So I hope this helped. This, I know, is a little long, and I apologize for that. Your assignments are going to basically be multiple choice, and they'll be asking you things. So definitely have these definitions written down, and when you put in your notebook the why, make sure you write the definition so you don't forget, and so forth, based on that. All right? Good luck. I will see you later. 1.3 homework is already posted, so you can have a look at that and come to class tomorrow with questions. Typical questions I've seen before is people sort of have problems with the differences between stratified and cluster, okay? And so we can talk about that some more. Anything that comes up, I'll try and do my best to help you. So look forward to your questions tomorrow, and I'll tell you a little bit more about my studies that I participated in. I've told you a little here on the video, but we'll talk to you next time. All righty, bye.